again. All right. So the question was if we actually, or the problem was, if we keep adding more and more data to our, let's say, representation, like let's say an integer year, like maybe let's say perhaps also a name, for example, character, string, name, and 50 of those names, maybe each name has at least 20 characters long, something like this. The representation has to take care of all these things together. So if you want to send this to a function, you need to send all of it to a function. Whoever actually needs to do anything about this thing, they need to consider all of these things together, right? So 5 different variables, 10 different variables. This doesn't make any sense, of course. Another, in that case, a natural way, more natural way and convenient way of doing this would be actually keep all these things in a structured type and then use that type and create an array of that type. So you can, in principle, you should be able to create a type and use create an array of that type. So what we'll do in this case is simply we'll say, okay, now I will create a type. The way that I create a type, I know how to do it. I do a type def, and I say, okay, this is going to be a structured type, and the name of the type is student record, for example, let's say. So this is my student record type. And then what I will do is perhaps, what do I have here? I will have an integer ID for this student. I will have, let's say, a double GPA, right? And I would have perhaps integer year and maybe a name, a string of, let's say 20 characters, and even more if I want to. Then let's say that how do I actually change, let's say, this print function here, print records, print student records. Then here, instead of actually doing that, what I do is I say, okay, student record. This is student record. I define my students is in this record, in this array. And I know that I will need, let's say, this many of those at most. This is the thing that I'm going to replace this guy with. Okay. And I can even do something like this. I can do say, okay, now assign to this some predefined things. Like, for example, let's say, okay, the first one was 123 for the first thing. Of course, I need to be careful here. Let me do for the time being just these. I don't want to add the name for the time being to this one. So ID, GPA, and year. So the first one is ID. The GPA is 3.9 and the year is 1. This is my first student. The second student is 124, 2.7, and 4. The third student is 125, 3.0, and 2. And my fourth student is 126, 3.8, and 3. So these are the initialization. Now I don't need these anymore. I can actually get rid of these. Then I will have a number of students here, and this is my student ID. And when I do a print record, instead of this guy, I will do, instead of this guy, I'll do another one. So print, let's call this print student records, a new function. So this way, print, let's say, student records. Then I don't need to send GPA, year, and all this stuff. Instead, I just say students here, and I am done. Now I go back to this function here. Print records was this. This is not the right function. I want to write a new one that actually does only take one array. Student, let's call this student records, and I will need only one array here, and that's it, right? This will be much simpler than here. What do? I say, now how do I access to this thing? I access the first student with this guy here, students I. This is my first student, and then I will go for the component that I want to print there, which is the first component is this guy. Then the second one is going to be simply this guy is the year, and the third one is this guy, which is GPA. Now you can see that the access to this array is as before. I get the fifth entry, second entry, third entry, whatever entry, which is indicated with 0 index in that square bracket. Now that gives me that entry. What type of entry is that? It's a structure type. How do I get access to the structure type ingredients of the components of the structure type? Use a point dot. And that operator or the point operator will give me access to it, which component, in this case ID, in this case year, and in this case GPA, right? So if I want to actually do this a little bit, let's say fancier, and I want to add the name, for example, here, right? I add the name. Of course, this might have a problem here, but doesn't matter, right? If I have a name here, I may add something. I don't want to do that one for timing, but there is no need to change this part. This is the same. This is going to stay this structure, or the prototype of the function is not going to change because I'm looking for student records, and student records is, oh, sorry, this is not right. Someone should have been warning me. Or warning, I don't see it. This has to be student records, right? So student record type students, then I don't need to worry about actually how you changed it. And if you have changed it here, for example, this one, and I don't, if I want to print it, I can print it. But if I don't want to print it, the function is going to stay the same. As long as you don't change the components here, this function doesn't need to be changed. If you want to print the name as well, what you do is you say ID for perhaps name here. Then you say this is a string. This is a year. No, I'm doing it in the wrong place. Doing it in the wrong place. I need to do it here. So this is the name. And this is string. And this is the year. And where does that go? That goes between the ID and the student year here. And I will say just the name here. You can see now that this entire array actually keeping each of these values for students, and each value for a student means a complex number of things, components. In this case, 4 components. One component is an integer ID. The second component is a double number GPA. The third component is the number of years that student has been at school. And the fourth component is a string of at most 20 characters with called name. And I can actually access this thing using just one array name. Each array entry is accessed with a square bracket. And then the rest of it is actually handled as if it is just a structured value. Okay, so this is the proper way of actually doing this, or more natural and convenient way of doing this. And you can see a few examples here. In this case, in the first example, I have the integer and double GPA. This is the student type, and I can have now the student list as an array, and access to those lists by individual of them will be actually accessed by an index, and each of these indices will have, each of these structured data will have 2 pieces or 3 pieces or 4 pieces, depending on how many things that you have here. So this is very, very easy way of now manipulating and carrying around these repeated type of complex values, complex in the sense that kind of let's say user-defined values. And in this case, the user-defined value here is actually an integer and a tuple of an integer and a double. Here, there is another example. This is the, let's say, representing a point in a 2D space, like a Cartesian space. Then you have two double numbers, perhaps. In the case of, let's say, a 3D space, this would have been, let's say, three numbers, double X, Y, and Z. Now you can have, for example, in graphics that you're going to see later on, that in graphics you can have, let's say, 2D points, many of those 2D points or 3D points or lines or whatever that what you want to actually add. So this is a very convenient way of, let's say, representing an array of complex types, right? So there is an example here in the book, or in the this is from the book, and these are on the slides. You can have a look at them. And I'll do is I'll skip them talking about this one. But before that, there was a question. Okay, so let's actually write a few more functions before answering that question. So we know that this is not this guy doesn't make sense now anymore, because having these multiple arrays to keep the data this way doesn't make any sense. This is not very convenient. So we actually gave up on that one. So let's do a few different functions using this thing here. All right. So assume that I want to write a function that, given a, let's say, what I want to do is I want to return, let's say, given an ID, a student ID, like here, I want to return my my records for the student, meaning the name and perhaps the GPA and so forth. So my input is going to be, of course, student records, right? And these are student list, students, or student list. This is going to be, I need this number of students because I need to know the content or how many entries are there. So this is the function that I want to do. The return of this function can be many things, but what I want it to be is actually a type of record. So this means that when I find the student, I'm going to return the student's ID, GPA, year, and the name at the same time, because this guy actually of a structured type like this, which is this guy, has all this information. Okay, so let's write this function. This is going to be very simple. Since I'm returning a kind of a value, I need to create a local variable to keep that value. Assume that that's the I don't need to do it, but anyway. So let's do it this way. I'm gonna do actually a counting loop. I'm gonna go through the entire student list. So from 0 to number of students. So I'm gonna go through the entire list of students. What am I gonna do? I'm looking for the particular student with a student ID. So how do I get it? I say, okay, my student list is this guy, this one, and this is the I student. I want to check if this I student's ID is this student ID, right? Where is my student ID? Student ID. If this is the case, then I found my student. So if the student, I student, the ID of the I student is the student ID here, then I found my student. I can do whatever I want to do with it. All right. So what do? I want to actually return that particular record, return that particular value, which will include the ID, the GPA, the year, and the name. Okay. So assume that I'm going to actually make a copy of it. This is student. This is the student that I need to find here. So here, what I'm going to do is I'm going to say, okay, my found student has an ID, which is student's ID here, I and ID. This is my first part of the student. This is the first part of that thing. The second part is a GPA, right? I can do GPA here. And the third part is year. I will copy the year information. The fourth part is actually the name. I cannot do a copy of this sort using a string, of course. What do? I do a string copy, and I will copy my name from name here. Copied it, and here now I can return the student that I found. What if I cannot find this one? Maybe perhaps if I cannot find it, I want to actually have a empty thing. So SID perhaps means that -1, which I know that I haven't found anyone. And S maybe this would be sufficient. The rest of it is not going to be necessary. So I'm initializing the ID first to -1. If I found the ID, I know that it's not going to be a negative number. It could be a positive number. Then if I don't find it, when I look at the return of this thing, I'm going to say, okay, this student is there or not, or such a student is there. Let's do this one in a function called here in the main or whatever. So this could be main as well here. Let's do this one main. So now I have student records, this guy, and I have a student. My student just a variable for a student. And I want to say a student is what? Find student given my students and number of students and an ID and student ID in this case. All right. Where is the student ID? Student ID here. So this is the function call. What it's saying is that it will call a function. It will call this function with all my students and with number of them. I need to know how many do I have, and the given student ID, and it will actually get this student copy of this student. It will get a copy. Then what I can do is I can say, okay, if a student field is ID field is -1, then this means that I couldn't find the student, which means that could not find student ID, this guy here. You are trying to find the student ID. I could not find it. Otherwise, I found it, and I will print it. I will print the, let's say, student found student name, let's say is string, and this is a student name. So now what I'm doing is I'm returning from this function a record or a structured value, which has four pieces, four components: ID, GPA, year, and name. And I am actually first checking this one, the ID, if I found it, because I know that a student will have always a non-negative number as an ID. And in my function, if I couldn't find it, I will actually make my ID -1, and then I will check it here. I will say, okay, I'm looking for student number 25, 125. If I find it, I will actually go here. If I don't find it, I will go here. And I hope this answers the question someone asked. I think it was, let me see, where is it? It was Mustafa, I think. No, he says, this doesn't mean, or he didn't mean this one, but at least someone said, okay, Cam, how do we use those structure type as a return value? This is how you use it. Okay. Anybody else? Any other questions? Okay, this is answered now. All right, good. Questions? Any questions? Typedef struct'la struct arasındaki fark ne? What do you mean? Okay, Now he has a question. He's saying, okay, why do I need this type def here? So he's saying, what is the difference? What is this guy here? This is actually the mechanism to define a type, but the type is not there. I mean, it's defined, but it is not assigned to anything yet. So this is just a temporary definition. In order to actually store this thing somewhere and refer it later, you need actually this type def info thing here. So this type def says, I have this type. I could have actually, for example, done this way, type def integer, my integer. This says, I will actually create a new type. This is my integer. And this type is simply just an integer, existing thing. I'm just calling integer my integer. This is the same thing here. I am calling this type my student record type. And I want to use that name later on to actually refer to that type. If I didn't do type def, this could have been gone. This wouldn't be actually referred again and again and again. I cannot find it. I need to store that name for that type. All right, this is the difference. And there will be some other differences that we'll discuss later on. Okay. Someone's asking, student direct döndürmek yerine student ID'sini döndürseydik daha mantıklı olmaz mı? Of course, he's saying that why did you actually return here the student record? Because this is what I wanted to do. If you wanted to actually write this function, for example, this one, for example, then you would have returned only the ID or the GPA or whatever, right? So here, this function, I wanted to actually get the entire thing for the student, everything for the student, not just the ID, but also the potentially, I want to ask the name of the student or maybe the GPA and so forth. Okay, so let's actually do one more thing. I want to write a function that I want to know. This is what I want to do. Okay, a function that calculates, okay, the average GPA of year K student. So I want to write a function and I want to give your function, or I want you to write a function, and your function should take all my students, the list of students, and I will say, okay, for example, I will give you another parameter, let's say 2, and you'll say, okay, I'm gonna actually find all the students, second year students, since the argument is 2, all the second year students, I will add their GPA is up, and I will actually tell you the average GPA for the second year students. This is what I want to write this. I want to write this function. Okay, so this is gonna return a double number. So average GPA for given year. What should be the parameter of this function? Someone tell me what parameters should I actually have for this function? I'm gonna have these two for sure, right? These are the students and my number of students. These are gonna be here. What else do I need to have? I need to have one more thing. Year, okay, integer year. Now, given this, what I want to do is I want to find all the students that is at that year in their studies, and I want to actually sum them up, their average. I want to find their GPA average. So how do we do this one? I say, okay, I have to find average GPA. Right? I want to find how many students, I don't know, n. And perhaps I'm gonna say, okay, this guy here. I'm gonna say now for all my students in my list from 0 to less than num students, all of them. I'm going to go for all those students. Of course, I'm not going to actually get all their GPAs. I'm going to get only the GPAs for the current years, whatever the current year is, those students. So meaning I'm going to take the students, the I student, I look at the year of that I student, and this should be the year that I am looking for. So if my student is in the current year, the desired year, then I will actually count him or her in. Otherwise, I'm not going to count them. All right. So what does it mean counting? I'm going to actually add their GPAs up. A GPA is this student's GPA here, right? And I need to know how many such students exist. This is my N, num students. Let's say num S, let's call this one for the time being. And I'm gonna do num S is 1. I'm just gonna actually increment this. And then at the end, what am I gonna do? I'm gonna return the average, meaning AGPA divided by some double number. I'm gonna convert it to a double number. What is this? Double here, and num S. This is the average GPA for the year, for the current year, whatever I am looking for. All right. Of course, I am missing two things. Tell me, what am I missing in this code? Someone tell me, what am I missing? I need to do num0 and one more. I need to do one more thing. Of course, I need to have these two accumulators. I have two accumulators, nums and AGPA. Those accumulators has to be initialized. So AGPA should be 0 and nums should be 0 as well. That's what I'm gonna have. Right. Then I can actually talk about, this will actually give me, for example, if my input is 2, all the students in the second year and their combined, their average GPA. All right. Good. Perfect. So we can do a lot of things. You can see that now the only thing that I want to emphasize here is this is the only argument that I'm going to actually have. As I change, for example, you can say, okay, if I changed and add here, for example, something else, int num classes. I added a num classes to this struct. Do I need to change anything in this function? Do I need to change anything in this function and the call of this function? The answer should be no. Why? Because I am sending this student record. It's still the same thing, except that it actually has one new argument or one new component. This doesn't change. This doesn't change. This doesn't change. And there is nothing that I need to change to actually reflect this added change. So I can easily update my record, and those functions that are not affected by that record doesn't need to be updated at all. I can maintain them simpler. Perhaps the print function is going to change and find student function is going to change. This one is going to change because I need to copy the number of classes here, but this function is not going to change. So this is very nice. So this way I am actually managing my data, especially repeated, or let's say not multiple data of the same type, in a much cleaner and concise way. Okay. Another possibility that you can see here, that if I need to return, for example, something from, let's look at it this way. I want to write a function. Let's consider that as well. My function should actually return, given an array. So I have an function is gonna, let's say, find max, mean, and let's say max, mean, and let's say average, or average is the same thing. Let's say max, mean. Okay, let's do these true numbers. So what I do is I give you a double array, a of size something, int n. I'll give you a double array, n entries, and I want you to return from this array the maximum number, minimum number, and mean of this array. All right. So we know how to do this one. We can easily say, okay, let's do this one. Since I need to return three numbers out of this thing, I will have, for example, double here for return value of what? Max value. And I will have mean value, double mean value. And then I will have another double for what? For mean value. I can write this function now. Right? This is one way of doing it. Now you can see that this is kind of cumbersome. Why? I have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5 parameters to a function. 2 of them are input, 3 of them are outputs. But 5 parameters, this is quite too many. And you can see it already. One thing that I can do is I can simplify this one. I can simplify it by like this. I want to say, okay, I want to do a type definition, which is going to be a struct. Say, okay, double mean value, max value, mean value, and perhaps what we have, mean value. So these are the values that I want to return. And what I'm going to do is I'm going to just say, okay, and I'm going to say this is, let's say, statistics type, stats type. And I'm going to say, okay, just return stats t here and get rid of all these other 3 parameters here. Now you can see that this function is much simpler in prototyping or in the declaration than this one. It will be doing the same thing perhaps inside here, but you can see that this has much more concise structure in it, structure to it, or the prototype definition is very, very simple, easier to remember, easier to write, right, and read. Perhaps also later on, let's say that you were looking for maximum, minimum, and mean values. And then later on, you remember that, oh, you know, I may need standard deviation as a statistics of one more statistics from this data. Then you just add it here. You say, okay, STD value, like this. Now, your function call didn't change at all by adding this particular new output to your data. Otherwise, what you would have done is you would have actually gone here and added for this one another form of this that should be like this, that will have another double number for STD value here. You can see that this will both change the definition of the function, the declaration of the function, the implementation of the function, as well as the calling sequence of the function, wherever you call them. Whereas here, what I need to do is I don't need to change the definition or declaration. I don't need to change the caller. Only thing that I need to change is I need to change actually wherever I am filling these values for stats underscore t type, right? So this is much more manageable in terms of actually implementing such a thing. You can see that by adding this or removing this is not going to change anything that I define here. Of course, the definition, the implementation is going to change. I'm not saying that's not going to change, but it is there, right? So how do we implement this one? For example, let's do this without this one for the time being. Let's assume that we are doing it without it here. what am I gonna do? I'm gonna say, okay, I have to go through this thing, I from 0 to I less than n and I plus plus, right? And I'm doing several different things. Since this is a double thing, I have I can define this way if you want to. So stats, where did the stats go? Stats t, my result, and my result is going to be having, first of all, for the first value, it's going to be 0, the minimum. Maximum is going to be for the time being. I cannot do this one, so I have to be very careful with this guy here. Let's do it this way. Let's start with R max value is my first value of my thing, and maybe also my R min value is also the first value of A, and R min, X, R max, and what else? And maybe the mean as well. Mean value is going to be 0. Sorry about that. No, that's okay. Mean value is going to be our mean. Our mean value is going to be the same as well. So A of this guy. So this is fine. Now what am I going to do? If our max value is less than the given I, then I say, okay, our max value is this value. This is the maximum, right? And then I will do the same thing for minimum. Minimum value, if it is bigger than your current input, then I will change the minimum value here. And then for the averaging, I don't need to do anything. I say just our mean value is just your current value added on top of it. And then here, our mean value is gonna be divided by number of entries. So this is gonna be entries and I am done. And then I will return the result. So this is my function. Okay. So if I want to add something to this one, for example, let's say, let's assume that we say I want to add second, let's say second max value. So let's say that I want to add max value second. So what do? This is the second max value that I'm going to keep. So I need to only think that I need to change here. These are going to stay the same. The only thing that I'm going to do is I'm going to actually write another condition here, perhaps, that will actually keep me the second maximum value. So it will change perhaps this guy and the other one and so forth, but this is fine. So the call to the function declaration and the call to the function is not going to change at all. All right. Any questions? Any questions? Am I recording this one? Yeah. Okay. So did you get the point here that by actually kind of structuring the output of a function or an input to a function for that matter with this type of type declarations or structured types, I can simplify the calling sequence or the declaration as well as the call to a function. I can simplify them both in terms of number of parameters that I need to actually give and also the potential changes that I might want to do later on. Add a new field or a new component or remove a component and so forth. All right. So this will make the interface, we usually call this also an interface to a function. The interface to a function is going to actually be kind of fixed. I don't need to change that. I don't need to change the interface. The only thing is that I need to make sure that the added thing doesn't change the semantic of the function. I need to take care of the semantic here. when I add maximum value to the semantic changes, so I need to modify some of these things here. At this line has to be modified somehow, or there has to be a new line added to this guy. But that's okay. That's another thing that we need to worry about in this particular case. But the input is gonna be the declaration of the function and the calling sequence for this function, or the calling statement or the expression, whatever, is gonna be simpler. It's gonna be uniform. It's gonna stay uniform as we change the structure itself as we go. All right. Questions? Any questions? No questions. All right. Perfect. If you don't have any questions, let's continue with the rest of the things that we were talking about. Now, we have another mechanism to actually do a new type, which is called the union types. As I said, the structured types, the struct actually is taking two sets or multiple sets and doing a Cartesian product of these. Given a set of, let's say, values S1 and S2, for example, you can create new types from this one by, let's say, taking one value from this one and another value for this one, and create a tuple, right? This is a Cartesian product of two sets. Another possibility is I just take S1 and find S2 as a union. So I have S1 is one set, S2 is another set, and I want to find the union of these two as my new set, new value set. Okay. So this is a kind of, this is another way, and C provides a mechanism for this type of these new types, or these kind of types, that you can actually have an union of two sets. So what do you mean by union of two sets? For example, let's say that S1 is an integer and S2 is a double. This doesn't make much sense, but let's do it this way. Maybe integer double is not very good. Let's find something maybe simpler. Maybe just a string, right? A string of, let's say the S2 is just, let's say, a name string of, I don't know, for example, it's a 20 character long. So you have two sets. One is an integer, for example, let's say the, I don't know, the some numbers. And another one is actually a set that actually is just names. Union of these two things means that I have in my new set, my new set is my new type, new set. I might have an integer, or I might have a name. For example, one could be part of this thing, or let's say Ali is also part of this set. All right. Now C says, I can do this one for you. C says, I can actually give you a type where you can keep either the name, either the integer or the string in the same variable. This is the true definition of union. I have two sets, different characteristics. They may have different values, doesn't matter. One of them is actually all the values that you can get with a 20 character long string. There are too many of them, or just integers. So I want to actually create a simple variable, a single variable that can refer either to an integer or a 20 long character string of or character array. So is this possible? Yes, C says this is possible. And the way that C actually does this is the keyword union. So this one is just very similar. It's almost the same thing as the struct, but struct was taking a Cartesian product of two sets. If I have, let's say, struct integer something and character something. So this means that you have both an integer and a string. If it was string struct, but union says either the string or an integer. So here I have a very simple one. Union is actually having an integer or a color character array or string color. So one of them is a string of 20 characters. The other one is just an integer number. So it says this variable here, this hair type variable hair data. In some cases, this may, for example, refer to number 10, depending on actually what you are doing inside. Or sometimes this might be actually just a string like this. Or 50, 30, and then maybe this is a hair color. Ali is not a color. So let's change this one so that Ali doesn't mind about this thing. So maybe someone actually has brown hair. Brown. And maybe someone is blonde. And then maybe this is again, the definition of this thing is an integer, but maybe semantic here is just 0 or 1. So 0 means actually that person is, let's say, wearing a wig, or maybe 1 is wearing a wig, or he's not wearing a wig, therefore he must have a natural color, let's say hair color. So this is a union type. This is what is called a union type. This means that I can actually use one variable, and depending on the context, that variable can have either of those types. They'll represent any of those types. In this case, I mean, union has to be two, in this case, in the union of two things. So it can have, in this case, it's two things. So it will have either an integer number at any given time or a string of 20 characters, at most 20 characters. So this is, again, very similar to structures, but it's not a structure. Structure is a Cartesian product. It means tuples. Here is just a union set. This means that I have now a new type that can contain all the integers as well as all the strings of 20 or less characters. So this is, first of all, this is a very important concept in set theory, in math, and computer scientists like these type of things to actually bring corresponding ideas in set theory or other things here so that they can actually prove certain things about languages. This has, from the theoretical perspective, it has a significance in that regard. And you are going to talk about these unions later on in C++. And then if we do it together in your third year, we are going to talk about these unions again in the context of programming languages, the theory of programming languages. So this is an important topic. This is the first part, the theoretical part. The second part of it actually it has something to do with also the efficiency of things in C, the efficiency considerations in C. And this is going to be more obvious when we talk about a little bit in deeper what this means. But one thing that you would ask a question or not right now is that, hey, you are saying that I can actually, so think about this way. I'm telling you that now you have a variable, let's say hair tx variable. I declared this variable. And I'm telling you, this variable can have a value, integer value, or it can have a correct string. So an integer is how many bytes? In this case, 4 bytes. So in the first case, it is 4 bytes. In the second case, when it is actually a string, how many bytes do I have? Exactly 20. So now look at this one. You are saying that your variable x can be actually pointing to anything, either a 4-byte integer or a 20-byte long or 20 character long string. So how do I actually represent this thing then? I need to actually, compiler should be able to represent this. These are not the same thing. These are completely different things. 4 bytes and 20 bytes are completely different. First of all, length is different, and 4-byte integer has a specific byte configuration, and 20 byte string or 20 character string has a completely different character byte representation or bit representation. How does C handle this one? So we are going to talk about this. This is an important thing, but C has a mechanism to handle this one, a simple mechanism, and based on and that mechanism is going to lead itself later on for some tricks that we can use to write efficient code in C, especially things like, let's say, embedded code, for embedded systems. So we are going to talk about how to do this interpretation and when to decide. So I decide this one, I use this one X, and then I actually did some assignment to X some place. And later on here, later on the code, how do I know what X is? Does X actually have an integer? Does it have an integer, or does it have, or it has, let's say, a string? How do I know? I don't know. Right now, I don't know. We have to think about this, and we'll talk about this. So what is going to be, how is the memory representation going to happen for union types? And also, how do we know at any given point what that variable has? And the first one is simple. C is going to offer a recipe for that. It's going to have a simple recipe. And the recipe is actually, it's going to allocate 20 bytes long. And it actually fill that 20 bytes, the largest byte, the largest memory is going to be actually allocated. And depending on what you're actually storing it, it will use the first parts of the storage. If it is 4 bytes, for example, integer, it will use the first byte for first 4 bytes. This is easy. The second one is more difficult. The second one is going to be left to user. The user is going to know what he or she, or the programmer is going to know what he or she actually is currently holding in X, in that variable, in that union variable. This is what we are going to discuss next week. Do you have any questions? Bu arada Atakan'ın doğum günüymüş. Yok pardon, Atakan'ın değil, kimin? Coşkun'un doğum günüymüş. Coşkun'un doğum günü kutlu olsun. Atakan yazmış buradan. Bilmiyorum doğru mu? Atakan'a inanarak diyoruz ki Coşkun doğum günü kutlu olsun. All right. Any questions? If there are no more questions or no questions at all, then we'll stop here and we'll